So today we're going to look at small angle approximations. And we have y equals sine x in blue, y equals x in red. And I'm hoping we can see that for very small values of x as we get close to 0, that the line y equals x and line y equals sine x look very similar and they almost rest on top of each other. So that means we can say that as x approaches 0, sine x is roughly equal to x, because we can see that their graphs look very similar when we have very small values of x. So these are the bases of the small angle approximations, but as you can see here, it only works if x is in radians. And if we think about it, when we're drawing our graph out, pi is equal to what? 3.14? If you think that's equivalent to 180 degrees. So if we try to do that with our graph in terms of degrees here, we can see that the line y equals x doesn't match up at all with y is equal to sine x, because when we're working with degrees, the axes here are just going up far too high for our y equals x line, so it only works when we're in radians. So here I have y is equal to theta, or y is equal to x, and we can see here, so you can see this bit here, that is the value of theta. So as we see, as we go away and get larger, it diverges, and if we go very negative, it diverges. But we can see here, so from about minus 0.7 there to about 0.5, 0.6, those lines are roughly the same. So we can therefore say that theta is roughly equal to sine theta, because y is equal to theta and y is equal to sine theta are roughly the same. Let's have a look at cosine. So this time you'll see that the graph I've drawn is not y equal to x, it's actually y is equal to 1 minus theta squared over 2. So we've got a negative quadratic here, which I think makes sense looking at what our cosine graph looks like for very small values of theta. So let's have a look at it. So we know the bigger or the more negative it gets, the more positive it gets, it diverges away from each other. But again, for very small values, so there theta is about 0.8, all the way through to about theta being minus 0.8, minus 0.9, those graphs are very similar. So we can then say that theta for cos, so cos theta is roughly equal to 1 minus theta squared over 2. Finally, let's look at tan theta. So we're using the line y is equal to theta, again, or y is equal to x, but we're using theta. And we can see here that, again, for very small values, the line y is equal to tan theta and y is equal to theta are very close to each other. So we can see, diverges when we get bigger, but here, so let's see, that value there is about 0.4, that value there is about minus 0.4. So for very small values of theta, we can say that tan theta is roughly equal to theta. So as we can see here, these are the small angle approximations it's showing you again. So y is equal to theta, y is equal to sine theta. So sine theta is roughly equal to theta when we have small values of theta. Here we have 1 minus theta squared over 2, y is equal to cos theta, they're roughly the same. So cos theta is roughly equal to 1 minus theta squared over 2, and y is equal to theta, y is equal to tan theta, they are roughly equal. So tan theta is roughly equal to theta for very small values of theta. So let's now have a look at how we can use the small angle approximations to answer some questions. So I've got my small angle approximations up here, and I'm basically going to replace sine theta, cos theta, and tan theta with these things if I'm given the prompts to do so. So we'll talk about what those are. So it says, when theta is small, we're talking about small angle approximations. So that is your key takeaway whenever you see something like that. You see, when theta is small, it's small angle approximations. So we need to find the approximate value. That's another indicator, because it's not the exact value, it's the approximate value. And we know they are not equal, but they are roughly equal for small values of theta. So what we're going to do is we're going to take this bit here. So if it's a 2 theta here, then it will roughly equal 2 theta. So if it's sine 2 theta here, it will equal roughly 2 theta. So sine 2 theta will roughly equal 2 theta. Tan theta, it's just a theta, so that will just roughly equal theta. And that is over 2 theta. Now we don't need to do anything with that because there's no sine, cos or tan, it just stays as it is. So that will become 2 theta plus a theta is 3 theta, over 2 theta, cancel out the thetas, we are left with 3 over 2. Let's have a look at this next question now where we've got cos involved. So cos is a bit more complicated because its small angle approximation is a little bit more complicated. So the main advice I can give you is instead of it being theta, if it's 4 theta, replace cos theta here with cos 4 theta. And everywhere you see a theta, replace it with the 4 theta. So what I might do here is I might just do that separately. So well, cos 4 theta is going to roughly be equal to 1 minus, and it's theta squared, so it's 4 theta squared. So whatever is next to that theta has to be part of it as well. So if it's cos 4 theta, the 4 theta, you replace any thetas with 4 theta. So it looks like that. And that will give us 1 minus 16 theta squared over 2, which would just be 8 theta squared, which would be 8 theta squared. So that would give me, so cos 4 theta, all that would give me 1 minus 8 theta squared. Take away the 1, all over theta sine 2 theta. So sine 2 theta is going to roughly just equal 2 theta. So that will become theta times by 2 theta. I should use my approximate value, not my equals, because it doesn't equal it. It's an approximation. So let's just tidy that up a bit. So the 1 and the minus 1 will cancel out, leaving me with minus 8 theta squared. And here I'd end up with 2 theta squared. Let's cancel the theta squareds out. We're just going to be left with negative 4 as our answer. So the next question is, show that when theta is small, part A, sine 5 theta plus tan 2 theta minus cos 2 theta roughly equals 2 theta squared plus 7 theta minus 1. And then it says, hence state the approximate value of sine 5 theta plus tan 2 theta minus cos 2 theta for small values of theta. So again, I know we're working with small angle approximations, but in an exam, that when theta is small is your indication I'm using the small angle approximations. So also exam technique, if it says show that, you need to explicitly state everything, because you obviously are working with small angle approximations. You need to state those, what you're using and how you get your answer, because it's telling you what the answer is. You need to show the pathway to get there. So I'm going to say, so for small values of theta, we know that sine theta roughly equals theta. We know that cos theta roughly equals 1 minus theta squared over 2, and tan theta roughly equals theta. So therefore, sine 5 theta will roughly equal 5 theta. We'll do tan. Tan 2 theta will roughly equal 2 theta. And cos 2 theta is roughly going to equal 1 minus 2 theta all squared over 2. Now the 2 theta squared will roughly equal 4 theta squared. So that will become 1 minus 2 theta squared. So now let's just substitute all that in. So therefore, sine 5 theta plus tan of 2 theta minus cos of 2 theta will roughly equal 5 theta plus 2 theta, and then it's a minus 1 minus 2 theta squared. And then we have just tidy all of that up. So that will roughly equal, so we'll have our positive 2 theta squared, got a minus minus. We then have our 5 theta plus our 2 theta, which is 7 theta, and then we have our minus 1. So we're now going to look at part B, and it wants us to state the approximate value. Now, the approximate value, that means we actually want a number. So that means this is the part where we substitute numbers in. I'm going to say, as theta tends to 0, or you can write the words tends to 0, that means that our 2 theta squared is basically going to equal 0. Our 7 theta is roughly going to equal 0. So therefore, you might have thought, oh, we need to do a quadratic or anything, but no, if it asks for the approximate value, you're basically just going to replace all your thetas with zeros and then see what's left over. So if we get that, then that means that so we have our 2 theta squared plus our 7 theta minus 1. That bit's going to tend to 0, that bit's going to tend to 0, which means we are just going to be left with minus 1. So the approximate value is just minus 1.